Sayın Rektörüm, değerli akademisyenlerimiz, değerli misafirler, kıymetli öğrencilerimiz. İzmir Kâtip Çelebi Üniversitesi Yapay Zeka ve Veri Bilimi Uygulama ve Araştırma Merkezi tarafından çevrim içi olarak düzenlenen 2. Uluslararası Yapay Zeka ve Veri Bilimi Kongresi'ne hoş geldiniz. Açılış programını arz ediyorum. Kongre Başkanı, İzmir Kâtip Çelebi Üniversitesi Yapay Zeka ve Veri Bilimi Uygulama ve Araştırma Merkez Müdürü Sayın Profesör Doktor Ayşegül Alaybeyoğlu'nun konuşmaları, İzmir Kâtip Çelebi Üniversitesi Rektörü Sayın Profesör Doktor Saffet Köse'nin konuşmaları, açılış oturumu, kapanış. Dear Rector, dear academicians, dear guests, dear students. Welcome to the second International Artificial Intelligence and Data Science Congress, organized online by İzmir Kâtip Çelebi University Artificial Intelligence and Data Science Application and Research Center. I would like to present the opening program. Speeches of Professor Dr. Ayşegül Alaybeyoğlu, Director of İzmir Kâtip Çelebi University Artificial Intelligence and Data Science Application and Research Center, and the President of the Congress. Speeches of Professor Dr. Saffet Köse, Rector of İzmir Kâtip Çelebi University, Opening Session and of the Opening. Kongremiz, İzmir Kâtip Çelebi Üniversitesi Yapay Zeka ve Veri Bilimi Uygulama ve Araştırma Merkez Müdürü Sayın Profesör Doktor Ayşegül Alaybeyoğlu'nun konuşmasıyla başlayacak. Our Congress will start with the speech of Professor Dr. Ayşegül Alaybeyoğlu, who is İzmir Kâtip Çelebi Üniversity Artificial Intelligence and Data Science Application and Research Center Director. Sayın Hocam, buyurun.
Sayın Rektörümüz, Rektör Yardımcılarımız, dekanlarımız, değerli akademisyenlerimiz, kıymetli öğrencilerimiz. İzmir Kâtip Çelebi Üniversitesi, Yapay Zeka ve Veri Bilimi Uygulama ve Araştırma Merkezi olarak düzenlemiş olduğumuz 2. Uluslararası Yapay Zeka ve Veri Bilimi Kongresi'ne hoş geldiniz demenin gururunu ve mutluluğunu yaşıyoruz. Kongremize katılıp bizleri onurlandırdığınız için çok teşekkür ederiz. Yapay zeka ve veri bilimi alanlarında geliştirilen yeni yöntemlerin ve bu teknolojilerin birçok farklı alanda uygulama örneklerini içeren uluslararası nitelikteki çalışmaların sunulacağı kongremizin bilim ve akademi dünyasına katkı sağlayacağı inancındayız. İzmir Kâtip Çelebi Üniversitesi Yapay Zeka ve Veri Bilimi Uygulama ve Araştırma Merkezi olarak hedefimiz, Cumhurbaşkanlığı Dijital Dönüşüm Ofis Başkanlığı ve Sanayi ve Teknoloji Bakanlığı tarafından hazırlanan Ulusal Yapay Zeka Stratejisi'nde belirtilen Dijital Türkiye Vizyonu ve Milli Teknoloji Hamlesi kalkınma hedefleri doğrultusunda kongre, dergi, eğitim, bilimsel etkinlikler ve proje faaliyetleri gerçekleştirerek ülkemizin yapay zeka alanında gelişim ve değişim sürecine katkı sağlamaktır. Yükseköğretim Kurulu'nun yeni vizyonu arasında yer alan Yükseköğretimde Büyük Veri Projesi'nin başlaması ve üniversitemizin de böyle önemli bir projenin uygulanacak olduğu pilot üniversiteler arasında yer almasının heyecanını yaşamaktayız. Yapay Zeka ve Veri Bilimi Uygulama ve Araştırma Merkezi olarak bu süreçte akademik ve bilimsel olarak her türlü katkıyı sağlayacak olduğumuzu belirtmek isteriz. Günümüz dünyasına rengini veren dijital teknolojilerin odağındaki ana unsur yapay zekadır yaklaşımlarıyla her daim yanımızda olarak çalışma motivasyonumuzu artırması ve merkez faaliyetlerimize vermiş olduğu destekten dolayı Rektörümüz Sayın Profesör Doktor Saffet Köse hocamıza en derin şükranlarımızı sunarız. Yapay zeka ve veri bilimi alanında çok sayıda bilimsel çalışmaları olan davetli konuşmacılarımız Sayın Profesör Doktor Tülay Yıldırım'a, Sayın Doktor Frank Hopgartner'a ve Sayın Doktor Şükrü Özan'a konuşmaları için şimdiden teşekkürlerimizi sunarız. Kongremizin düzenlenmesinde büyük emek harcayan Kongre Düzenleme ve Bilim Kurulu'na, heyecanla çalışan merkez ekibine, üniversitemiz Kurumsal İletişim Koordinatörlüğü'ne teşekkürü bir borç biliriz. 2 gün sürecek olan kongremize akademik çalışmaları ve katılımları ile destek veren tüm bilim insanlarımıza şükranlarımızı sunar, başarılı ve verimli bir kongre olmasını dileriz. Teşekkür ederim. Dear Rector, Vice Rectors, deans, academicians, and dear students. As İzmir Kâtip Çelebi University Artificial Intelligence and Data Science Application and Research Center, we are proud and happy to welcome you to the Second International Congress on Artificial Intelligence and Data Science. Thank you very much for attending our Congress and honoring us. We believe that our Congress, which will present new methods developed in the fields of artificial intelligence and data science and international studies, including the application examples of these technologies in many different fields, will contribute in line with the Digital Turkey vision and National Technology Initiative Development Goals stated in the National Artificial Intelligence Strategy of our country. Our goal as a center is to contribute to the development of our country in the field of artificial intelligence by carrying out congresses, journals, courses, scientific and project activities with the vision of National Artificial Intelligence Strategy prepared by the Presidency of the Republic of Turkey Digital Transformation Office and the Ministry of Industry and Technology. We are very excited about the start of the Big Data in Higher Education project, which is among the new vision of the Council of Higher Education, and that our university is among the pilot universities where such an important project will be implemented. As the Artificial Intelligence and Data Science Application and Research Center, we would like to state that we will provide all kinds of academic and scientific contribution in this process. We would like to express our deepest gratitude to our rector, Professor Dr. Safet Köse, for his support to our center activities and increasing our motivation with his approach of artificial intelligence is the main element in the focus of digital technologies that color today's world. We would like to thank our invited keynote speakers, Professor Dr. Tülay Yıldırım, Dr. Frank Hopgartner, and Dr. Şükrü Ozan for their valuable speeches in advance. I would like to express my gratitude to the Congress Organization and Scientific Committee, Center team, and the Corporate Communications Coordinator of our university, who put a lot of effort in this whole process. We would like to thank all scientists who supported our Congress with their academic studies and participation. We wish a successful and productive Congress. Thank you very much.
Sayın Kongre Başkanımıza teşekkür ederiz. We would like to thank Mr. President of Congress. Saygıdeğer konuklar, şimdi İzmir Kâtip Çelebi Üniversitesi Rektörü Sayın Profesör Doktor Safet Köse'yi arz ederim. Dear guests, now I would like to present Professor Dr. Safet Köse, who is Rector of İzmir Kâtip Çelebi Üniversitesi. Buyurun hocam.
Kıymetli katılımcılar, öncelikle hepinizi saygı ve muhabbetle selamlıyorum. Böyle uluslararası bir kongreye ev sahipliği yapmaktan duyduğum mutluluğu ifade etmek istiyorum. Teknolojinin baş döndüren hızla devindiği günümüzde kurumların ve en önemlisi toplumların tüm süreçlerinin değişime ayak uydurmasının bir zorunluluk haline geldiğini görüyoruz. Değişim ve dönüşümün her geçen gün hız kazandığı günümüzde yapay zeka üzerinde en çok durulması gereken konuların başında geliyor. Zira her geçen gün teknoloji alanında yeni bir değişiklik ortaya çıkıyor ve bu dönüşüme ayak uyduramayanlar diğerleri karşısında dezavantajlı bir konumu kabullenmiş oluyorlar. Giderek makinelere, makine öğrenmelerine, nesnelerin birbiriyle iletişimine dönüşen iş yapış biçimleri ve süreçleri insandan bağımsız ama insan gibi iş yapan sistemlere yerini bırakıyor. Bu noktada dijital dönüşüm kaçınılmaz bir zorunluluk olarak karşımıza çıkıyor. İşte yapay zeka teknolojisi ve ona yönelik çalışmaların içinde olmak, öncü olmak ve dönüşüm süreçlerinde toplumsal sistemlere odaklı bir bakış açısı benimsemek, stratejik düşünen ve tüm alanlarda liderlik arzusunda olan ülkeler için bir zorunluluk olarak görünüyor. Toplumların ve insanlığın geleceğinde giderek daha önemli işlevleri yerine getirecek olan yapay zeka, doğru yönetilmediğinde tüm aşama ve süreçlerde sorunlar anlamına da geliyor. Özellikle teknoloji ve bilgi işlem süreçlerinin robot bilimiyle birlikteliği, gelecekte bu araçların iş ve işlevlerinin yaygınlaşması, üretimden savunmaya tüm süreçlerin insandan bağımsız hale gelmesi gibi sonuçları doğuracaktır. Saygıdeğer katılımcılar, teknolojik gelişmeye kayıtsız kalmak treni kaçırmak ya da çağın gereklerinden uzaklaşarak geride kalmak anlamına gelecektir. Teknolojiyi kullanan ülke modundan onu üreten devlet olma yolunda hızla ilerleyen ülkemiz için akademinin yol göstericiliği her zaman önemli olmuştur ve bundan sonra da önemli olacaktır. Konuyu disiplinler arası bağlamda ele almak, diğer gelişmeleri irdelemek son derece önemli hususlardır. Ve bilimsel organizasyonlar bu etkileşimi sağlama açısından son derece yararlıdır. Konuya disiplinler arası bakış hususunun bu noktada altını ısrarla çizmekte yarar görüyorum. Bu teknolojileri geliştirmek elbette son derece önemlidir. Günümüzde ülkemiz başta olmak üzere savunma sanayinin en etkili biçimde yapay zeka teknolojilerini kullandığını görüyoruz. Aynı şekilde sağlık alanının giderek bu uygulamalara ağırlık verdiğine de şahitlik ediyoruz. Mühendislik alanları zaten işin mutfağında yer alıyor. Ancak konunun toplumsal sistem, yapılar ve insan odaklı ele alınmasının gerekliliğinin de altını çizmek gerekiyor. Robotların ya da yapay zeka kullanan sistemlerin yaygınlaşmasında kolaylaştırıcı işlev önemli bir faktör olsa da bireyi tamamıyla süreçlerin dışında tutan bir sistemin ya da insanın yok kabul edildiği süreçlerin sonuçlarının tartışılmasında yarar görüyorum. Aslında sosyal işleyişi insanın en değerli yaratılmış olduğu gerçeğini değiştirecek, bir diğer deyişle nizamı bozacak, toplumun huzurunu kaçıracak robot teknolojilerinin geniş perspektifte ele alınmasında, olumsuzluklara ilişkin senaryoların bugünden akılda tutulmasında yarar gördüğümü ifade etmek istiyorum. Bu yönüyle konunun sosyal bilimler çerçevesinde irdelenmesinde fayda olduğunu da özellikle belirtmek istiyorum. Bu teknolojilerin yapay olması ayrı. Ama zeka boyutu bir tür bilgi biriktirmeyi, bilgiyi olumlu ya da olumsuz kullanmayı ifade ettiğini vurgulamak gerekiyor. Bilginin güç olduğu bir küresel sistemde hangi bilginin nerede tutulduğu, ne için kullanıldığı gibi hususların veya amaç ile araç arasındaki kullanımsal farkın gözden kaçırılmaması gerektiğini hatırlatmak isterim. Konu olumlu, olumsuz, insani ve tabiat dengeleri çerçevesinde derinlemesine ele alınmalıdır. Bu toplantıların bu konulara da yönelik çıktılar üreteceğine inancımı ifade etmek istiyorum. Geniş bir çerçeveden konuyu değerlendirmesi muhtemel bu uluslararası bilimsel organizasyonun sonuçlarının ülkemiz ve tüm insanlık için hayırlar getirmesini diliyor. Teknolojinin savaşlara değil, barış ve huzura aracı teknikler olarak kullanılmasını temenni ediyorum. Emeği geçen ve katkı veren herkese şükranlarımı sunuyorum. Kongremizin hayırlara vesile olmasını diliyorum. Teşekkürler, saygılarımla.
Sayın Rektörümüz Profesör Dr. Saffet Köse teşekkür ederiz. We would like to thank our Rector Profesör Dr. Saffet Köse. Saygıdeğer konuklar, şimdi de açılış oturumumuzu arz ediyorum. Davetli konuşmacımız Yıldız Teknik Üniversitesi'nden Sayın Profesör Doktor Tülay Yıldırım'ın konuşmaları, davetli konuşmacımız Sheffield Üniversitesi'nden Sayın Doktor Frank Hopgartner'ın konuşmaları, davetli konuşmacımız Adres Gezgini kurucu ortağı Sayın Doktor Şükrü Ozan'ın konuşma videosu, akademik bildiri sunumları. Dear guests, now I would like to present our opening session. Speeches of our invited speaker, Professor Dr. Tülay Yıldırım from Yıldız Technical University. Speeches of our invited speaker, Dr. Frank Hopgartner from Sheffield University. Speech video of our invited speaker, Dr. Şükrü Ozan, who is Adres Gezgini co-founder, academic paper presentations. Davetli konuşmacımız Yıldız Teknik Üniversitesi'nden Sayın Profesör Dr. Tülay Yıldırım'ı Challenges with Data and Privacy in Artificial Intelligence başlıklı konuşmalarını yapmak üzere arz ederim. Dear guests, I would like to invite our invited speaker, Professor Dr. Tülay Yıldırım from Yıldız Technical University to make a speech titled Challenges with Data and Privacy in Artificial Intelligence. Sayın Hocam buyurun.
Çok teşekkürler. Sesim rahat geliyor mu acaba?
Evet hocam.
Tamam. Herkese günaydın. Şimdi ben ekrana da baktım. Yabancı bir kişi de görmedim. Bilmiyorum. Arzu ederseniz Türkçe'de devam edebilirim. Sunumu aslında ben İngilizce hazırladım. Ama herkes Türk olduğunda bazen Türkçe daha rahat birbirimizi anlıyoruz diye düşünüyorum. Olur da hani yabancı bir olursa belki hani araya girip uyarırsanız devam edebiliriz. Ben sunumu önce ekrana paylaşayım. Bu arada da Bu arada da sizlere çok da teşekkür etmek istiyorum. Gerçekten hani çok önemli bir şey burada yaptığınız. Yani ülkede tabii ki bir şeyleri sürekli yapmak durumundayız. Ekranı büyüttüğümde gözüküp gözükmeyeceğini bir önce lütfen kontrol edelim. Bazen bir sıkıntı oluyor. Tam ekran görebiliyor musunuz?
Evet hocam.
Tam ekrana geçti değil mi?
Hı hı.
Tamam, peki. Şimdi gerçekten bazı şeyler hiç kolay değil. Özellikle kongre düzenlemek kolay değil. Ayşegül Hocam'ı bu konuda çok tebrik ediyorum. Hiç kolay şeyler değil bunlar. Bizler de çünkü yaklaşık 20 senedir akıllı sistemlerde yenilikler ve uygulamaları konferansını düzenliyoruz. Yani 20 seneyi neredeyse devirmek üzereyiz 2004'ten beri. Başlangıçta böyle az katılımla ve daha şey oluyor ama bir bakıyorsunuz büyümüş bir sürü kişi sizi tanıyor. Ayşegül Hocam'la da oradan tanışıyoruz aslında biraz. Kendisini ve yakın arkadaşlarını, ekip arkadaşlarını da buradan tebrik ediyorum. Ben bugün sizlere aslında çok önemli bir konu olan, üzerinde çok durulmuyor belki ama yapay zekadaki hem verilerle ilgili bir takım kısıtlar, bir takım da zorluklar üzerinde konuşacağım. Biraz daha da önemli olan ve son 1-2 yıldır pandemiyle birlikte önemi artan mahremiyet dediğimiz kişisel veri, privacy konusuna biraz girmek istiyorum. Çünkü privacy konusunu nedense biz araştırmacılar yıllardır hep ihmal ettik aslına bakarsanız. Çok fazla üzerinde durmadık. Ama ben bir doktor öğrencimle birlikte birkaç senedir bu konu üzerinde çalışıyorum. Pandemide başlayınca biz çalışmalarımızın ne kadar önemli olduğunu daha da fark etmiş olduk ve ne kadar az çalışma olduğunu da fark etmiş olduk aslında. Bu yüzden de bugün bu konu üzerine biraz değinmek istedim. Öncelikle biraz kısacık dijital transformation dediğimiz bizim Endüstri 4.0 ve Society 5.0 diye adlandırdığımız, toplum 5.0 diye adlandırdığımız birkaç kavram var. Kısaca onlardan bahsedeceğim. Daha sonra data challenge dediğimiz veya data constraints dediğimiz veriyle ilgili bizi kısıtlayan bazı zorluklar. Yani biz hep büyük datadan konuşuyoruz ama başka şeyler de var arka planda. Bizi çok zorlayan yapay zeka ile ilgili çalışmalarımızda, özellikle veri biliminde ve privacy preserving ya da privacy enhancing dediğimiz tekniklerden biraz bahsetmek istiyorum. Birkaç tane de kendi yaptığımız uygulamaları da hani içerisine azıcık entegre edecek şekilde, doğrudan değil ama sadece hani bahsedecek şekilde uygulama alanlarının neden önemli olduğunu, bu konuların şeyine varmak istiyorum. Yani bunları anlatmak istiyorum sizlere. Şimdi The Age of Digital Transformation diyoruz. Aslında biz yaklaşık bir 10-12 sene kadar önce, yani 2010'ların başlarında Endüstri 4.0 dediğimiz bir döneme girdik. Ve o sıralarda biz Information Society dediğimiz bilgi toplumu olarak adlandırılıyorduk. Ve zaman içerisinde bu Alman konsepti olarak başlayan ve karanlık fabrikaların ortaya atılıp işte enerjiyi fazla kullanmayacaksınız, İçeride robotlar çalışacak ve her işi robotlar yapacak. Böyle bir akıllı ve karanlık fabrikalar konseptiyle ortaya çıkan bir şeydi dijital transformation. Fokusu sadece production, yani üretime odaklı. Zaman içerisinde tabii ki cyber physical systems dediğimiz hem siber hem de fiziksel prosesleri böyle içeren bir yapılar ortaya çıkmaya başladı. Hatta bu yapının içerisinde bir de biyolojik yapılar da var. Yani insanda, human in the loop dediğimiz, insan da çevrimin içerisine giriyor. Bir tarafta insandan veya başka bir şeyden işte sensörler vasıtasıyla bilgiler topluyorsunuz. Sonra bulut ortamına atıyorsunuz ve bulut ortamında da gidiyorsunuz, bunları değerlendiriyorsunuz. Bu noktada da tabii ki IoT kullanıyorsunuz, Wi-Fi kullanıyorsunuz, sensör ağları kullanıyorsunuz. Yani çeşitli uydu haberleşmesi kullanıyorsunuz. Çeşitli haberleşme tekniklerini kullanıp dönüyorsunuz, değerlendirdiğiniz bilgileri tekrar fiziksel bir ortamdaki bir cihazın, mesela işte bir robot kolu uzaktan kontrol etmeniz gibi bir durum. Burada tabii ki bu sistemler ağırlıklı olarak yapay zekayı, IoT'yi, işte bulut hesaplamayı kullanıyor. Hatta VR, AR, MR dediğimiz bizim virtual reality, augmented reality benzeri şeyleri kullanıyor. Büyük veri var artık elimizde. Çok önemli bu. Arkasından da güvenli bir ortamda olması gerektiği için de cyber security kavramını ön plana çıkarıyor. Tabii bunlar nedir? Technological development dediğimiz gelişmeler. Teknoloji çok hızlı gelişince tabii toplum da buna nasıl ayak uyduracak süreci ortaya çıkıyor. Japonlarda 5 sene kadar önce, çok değil inanın, çok yakın bir tarih, 5 sene ama çok hızlı gelişen bir Society 5.0 dediğimiz toplum 5.0'a geçiyoruz. Artık biz süper smart society olduk. Çok akıllıyız gerçekten. Teknolojiyi hızla kullanıyoruz. Japonlar diyor ki Almanların geliştirdiği bu süreç halkı nasıl etkileyecek, insanları nasıl etkileyecek? Bir taraftan da buna bakılıyor. Ve burada birkaç şey böyle göstermek istiyorum. Çok da hoşuma gidiyor. Önce yapay zeka var, her şey var işin içerisinde. Bir bakıyorsunuz her yerden verinin yağdığı bir büyük veri kavramı var. Bir tarafta işte dijital fabrikalar var, dijital ikiz kavramı var. IoT ile her şeyi birbirine bağlıyoruz. Hatta IoT bırakın Things of Things gibi kavramlar var. Şeyleri şeylere bağlayacağız. Yani interneti nasılsa ortadan kaldıracağız gibi bir sürü şey var. Ve Smart City, Smart Life dediğimiz akıllı yaşama doğru gidiyoruz. Her tarafımızda akıllı bir şeyler olsun istiyoruz. Ama şu 5 sene gerçekten çok enteresan bir 5 sene. 5 sene önce bu yayınlanıyor. Japonların Society 5.0 kavramını ortaya attıkları dönem. Odağında insan var. Yani Endüstri 4.0'ın odağında üretim vardı. Burada odakta insan var ve çok enteresandır. O sırada current society diye adlandırılan şey 5 yıl önce bilginin falan çok fazla paylaşılmadı. Paylaşılsa da çok iyi değerlendirilmediği bir dönem gibiyken bir anda hele de pandemiyle her şey o kadar hızlı gelişiyor ki tabii burada yapay zekaya, derin öğrenmeye, görüntü işlemeye, doğal dil işlemeye vesaire çok teşekkür etmek lazım veri bilimine. Teknoloji çok hızlı gelişiyor ve bizler artık milyonlarca veriyi paylaşabiliyoruz. Çok ciddi bir bilgi akışı var. Sosyal açıdan insanlara yardımcı teknolojileri çok hızlı gündeme getirmeye başladık. İşte uzaktan hasta takipleri, özellikle lojistik sektörü, e-ticaret sektörü korkunç bir hızla gelişti bu noktada. Ve tabii bunların hepsi çeşitli problemler ortaya çıkarmaya başladı. Biraz sonra onlardan da bahsedeceğim. Evolution of Systems diyoruz. Yani biz bu döneme gelirken ne oldu aslında? Önceleri, çok önceleri diyeceğim, çok önceleri ama benim yaşım, benim öğrenciliğimde aslında, üniversite öğrenciliğim sırasında conventional dediğimiz bizim çok klasik, basit kontrol mekanizmaları vardı aslında. Yani çok temel elektronik cihazlarla bir takım işler yapıyorduk. Arkadan smart systems dediğimiz daha çok programlayabildiğimiz, adaptif kontrolda olan, mesela evlerde işte hava karardı, ışıklar yansın, perdeler kapansın gibi kontrolleri yapan, akıllı diye adlandırılıyor ama aslında çok da akıllı olmayan ev sistemlerinden bahsettik. Daha sonra intelligent systems dediğimiz bir noktaya doğru gitmeye başladık. Şu an esasında şu ikisinin arasındayız. Yani smart systems ve intelligent systems dediğimiz yerin ortasında bir yerlerdeyiz. Bir taraftan da öğrenen bir takım yapılar ortaya çıkarmaya çalışıyoruz. Yani bir eve girdiğinizde işte mimiklerinizden ruh halinizi anlasın istediğiniz müziği çalsın gibi mesela, veya hemen kahveyi, çayı ocağa sürsün. Size önceden programlanmayan ama size bakacak, bugün sinirli bu, işte şöyle yapar normalde sinirliyken, veya üzgün görünüyor, şunu yapar gibi size öğrenerek hareket eden kısımlar olması gerekiyor intelligent systems'ta. Ve smart sistemler daha çok şöyle söyleyeyim size, sensör ve ölçüm ağırlıklıyken burada alınan ölçümlerin değerlendirilmesi, yani veri analizi aslında çok daha önemli. Yani data science daha önemli bir hal alıyor. Ve ileriye doğru experience diyoruz biz, her şey dahil. Yani çevredeki her şeyi birbirine bağlıyorsunuz, bütün bilgisayarları bağlıyorsunuz, hepsi ortak kararlar alıyor falan. O birazcık böyle hem ütopik hem de korkutucu, onu da söylemekte fayda var. Hemen hemen her tarafımız artık akıllı teknolojilerle dolu. Smart City, Smart Grid diyoruz, Smart Home Systems. Ulaşımdan fabrikalara, tarıma, sağlıktan finansa, ne ararsanız her tarafa artık bir Smart Data Intelligence kavramı girmeye başladı. Bu da şunu diyor aslında, arka planda yapay zeka veya karar destek sistemleri veya veri analizi, data science dediğimiz veri bilimi, veri mühendisliği çok çok ön plana çıkmaya başladı. Son birkaç yıl hele pandemi bizi iyice zaten bu noktaya götürdü. What is Big Data diyeceğiz aslında. Ben yine öğrenciliğime gideceğim. Desktopların olduğu dönemlerden bile önce galiba, ya ben yaşım çıktı orada. Burada yaşım çıktı. hobbies dediğimiz aslında çok basit elektronik devreler vardı aslında gerçekten. Yani ben bir Amstrad bilgisayarda parmaktan nabız atışını böyle ekrana çizdirmeye çalışıyordum. 2 gün önce bitirme sınavlarında öğrencilere anlatıyorum. Vay hocam nasıl yaptınız şimdi bile zor falan. Yani zordu ama yapılabiliyor diyorum. Ama gerçekten hafızalar o kadar zayıftı ki yapay zekada şimdi milyonlarca veriye eritebiliyoruz. Biz çok basit bir yapay sinir ağı benim yüksek lisans yaptığım 90'lı yılların başında bilgisayara verdiğimizde 2 gün çalışırdı. 2 gün sonra bir bakardık bilgisayar kilitlenmiş. Yani o kadar az veriyi dahi işleyemiyorduk. Şimdi neredeyiz? Zettabyte'lar, yottabyte'lar seviyesindeyiz. It can fill the Pacific Ocean diyoruz aslında buna. Çok çok ciddi boyutlara geldi. Bu arada tabii Big Data Analytics dediğimiz bir şey var. Onun 3 V'si ve 3 S'si, değiştirmek istemiyorum bu kavramları. Volume, Velocity and Variety dediğimiz kavramlar verinin ne kadar ve neden karmaşık olduğunu bize anlatıyor aslında. Çok hızlı bir şekilde çeşitli kaynaklardan veri yağıyor ve büyüklüğü de çok fazla. Bu da veriyi çok komplike bir hale getiriyor. Nereden geliyor bunlar? Sources of Big Data, Social Networks başta. Her gün Facebook, Twitter, TikTok bilmem ne varsa, Instagram, milyonlarca fotoğraf yükleniyor, belge yükleniyor, işte videolar yükleniyor. Onun dışında mobile phone veya wearable devices dediğimiz işte akıllı saatlerden birçok bilgi toplanabiliyor. Navigasyon hepimiz kullanıyoruz. Online alışverişler yapıyoruz. Bunların sayesinde her tarafımızda kamera var, bakın bizi izliyor. Sensörler var, ölçümler alınıyor birçok yerden, hava sıcaklığı vesaire. Her yerden bilgi alıyor anlayacağınız ve veri kaynakları çok fazla. Yine Big Data 6C dediğimiz bir kavramdan da bahsetmek istiyorum ben aslında burada. Şunu da söylemekte fayda var. C ile başlayanlarda yani connection, customization, cloud computing, cyber, community, content, context gibi kavramlar o kadar önemli ki bu kavramlarda bizi esasında ilgilendiren şeyi söyleyeyim. Sensörlerle her şeyi bağlıyoruz, bilgiyi kişiselleştirmeye başladık ve paylaşmayı çok seviyoruz aslında artık. İçerik de çok önemli çünkü o içeriğe bakarak anlamlar çıkartıyoruz, ilişkiler kuruyoruz ve bu içerikle gidiyoruz. Ne yapıyoruz aslına bakarsanız? Bu içerikle gidip işte kişisel bilgileri kullanarak recommender systems dediğimiz sistemler ortaya atıyoruz ve recommender systems'larla gidiyoruz. Mesela bir tane işte kitap alacaksınız veya film seçeceksiniz. Hemen dönüyor diyor ki sistem, bak bunu alan bunu da aldı, bunu okuyan bunu da okudu, bunu seyreden bunu da seyretti şeklinde. Bu arada tabii ki burada kritik olan şeylerden biri de şu, veriyi artık klasik hard disk, flash memory gibi yerlerde saklayıp depolayamıyoruz. Çok büyüdü çünkü. Onun için buluta atıyoruz. Cloud computing çok önemli oldu. Buluta atınca da tabii ki güvenlik ön plana çıktı. Modellerin ve bilginin gidiş gelişi sırasındaki yolların aslında ciddi anlamda kontrol edilmesi gerekiyor. Tabii ben diyorum ki hani, of course the big data itself is a very big problem. Tamam, büyük veri çok büyük problem. Başa çıkması çok zor ama farklı challenge'lar da var. Özellikle sağlıkta çok karşımıza çıkan. Sağlık dışındaki sektörlerde de çıkıyor ama sağlık şu an o kadar gündemde ki ve en zor veri analizi orada olduğu için söyleyeyim. Karşımıza bambaşka problemler çıkıyor. Mesela insufficient data. Bu sağlıktaysa mesela şu olabilir. Çok nadir görülen bir hastalık olabilir veya hastalık hani çok can yakan bir şeydir. Bir ara biz akciğer kanseri için veri toplamak istedik. Zordu yani. Onu o kadar kolay şey yapamadık. Bunu şöyle söylemek istiyorum ben aslında. Insufficient data dediğimiz şey eksik, yani eksik bir şey. Sensörlerden de eksikleri gelebilir. Burada tabii ki data collection issues dediğimiz meseleler var. Inconsistent data, missing data. Bununla çok sık karşılaşabiliyoruz. Especially in data coming from the health sector. We encounter such situations very often. Burada gerçekten now we are working on an e-triage system. So you know, the emergency rooms, everything is emergent. That's why, you know, the person cannot, you know, enter data correctly in that, you know, the Kâtip environment. So that's why usually, you know, we could get some inconsistent data and missing data. So another thing is the data content about data challenges and constraints. Data could be in the format of image, signal, text, or mix of them. For example, when you look at the document, sometimes it includes some photographs, or sometimes it includes text, both together, you know. And the data identification is also important, because data could be in numeric format, symbolic format, or in, you know, the healthcare situation. For example, the relationship between disease elements and patient factors and the appearance of clinical symptoms, which is the semantic data. So there are also, you know, the different expert opinions when the data were labeled. You know, it could be biased data depending on the person, you know, the human expert, because the human expert could put his or her idea on the data. Especially it's important when we, you know, consider about gender or race. We usually see this sort of data problems in, for example, human resources. Another important thing is the data privacy. We need ethics committee permissions, and also we have to secure the data all the time. These are the most important things when we try to handle with data. Also, there are other challenges and concerns on legal processes. Actually, there are many uncertainties in strategies, purposes, targets, in the management of processes, and also in practice. And one of the most important things is the personal data. We are using personal data, and it brings us privacy problem that we need to handle with that. Now, I would like to say the difference between data and information. And information is defined as knowledge gained through study, communication, research, or instruction. But data itself is actually, maybe we could say it's nothing. If you just have a raw data, it's just nothing. But if you analyze it, so you could get a lot of knowledge about a person or about a mission or whatever, about this, you know, the process. You could get a lot of knowledge about that. So the information is the perception of those pieces of knowledge. So it means that data is a collection of facts, while information puts those facts into context. So the data classification, another, you know, the fine line, I took this from a social media, which is very nice. There are different kinds of data, but the thing is, just starting from a zero-part data, you could go through somewhere else. You know, these kind of data could be used in recommender systems easily. At the beginning, it's okay. You know, you are buying something, it's great, and then last year it says that last year you did this. Oh, you need to do this. So you need to buy this one. And lots of examples could be given about this one. These are actually okay. As a consumer, we like actually our experience personalization, but these are excellent input data for recommendation systems. So when we think about deeply from a privacy perspective, it's actually pretty alarming. We have to think about it. Sometimes it's even scary, because you don't even know how much data, how much knowledge, how much information you are giving to someone else at the same time. So types and structures of data also important here. Data types that should be handled with care in terms of privacy, these are the data. So what are these? Location data. It shows the location history of a person. So another data is the data relating to a social network, communication network, or physical network. We call it graph data. Then also we have time series. It includes a lot of information about, for example, census information, foreign exchange information, whatever. So the time series data contains an element of updating in time, and this type of data usually gives very important information to some users. Another thing is the data acquisition phases. Most of us, actually, I'm sure most of us, the flow of these data acquisition phases. We have to create the data at the beginning. This is very important. Sometimes you can enter the data in manually, but if you enter data in manually, just as I given as an example about the emergency room, so it could make the data insufficient or the missing problems. So this is very important when you enter the data manually. Sometimes you could create the data with an external acquisition. Also, you can capture data from devices, from sensors, cameras, or different kinds of sensors, pressure sensor, for example, temperature sensor, radar and lidar. So when you create data, second step is to store this data in a secure way. We usually need to, get backups of data, so recover the data. That's why we have to store this data. And when we did all these two steps, so it comes to the usage of data. So you could view data, process it, modify it, save it, or share it, whatever it is. At the end of this one, data archival also another important thing, because it's the copying of data to an environment where it is stored in case it's needed again in an active production. But how much data you could put in an archive, it's not feasible. You cannot, store data in an archive, because it would be a huge amount with time. So what you have to do, sometimes you have to purge or distract this data, some of them. But I just want to say that in all these phases, in all these 5 phases, we have to use some protection schemes or methods to ensure privacy. This is very important. So what are the privacy threats in data analytics? So the surveillance is important, because especially e-commerce, because we are using the e-commerce sites very often. In last 2 years, everybody knows that. So many organizations, including retail, study the customers' buying habits and try to come up with various offers and value-added services. So also the third-party data analyst can make some sensitive information freely from your data sources. So disclosure is important. Another thing is the discrimination, because the discrimination is the bias or inequality which can happen when some private information of a person is disclosed. So whenever some private information of a person is disclosed, so it can even lead to personal embarrassment or abuse. So we have a lot of privacy threats in terms of data analytics. I have to say that. So by especially inappropriate use of social media, we usually, the users are usually upload very, very important personal data into the public domain, which leads to privacy threats. So what are the privacy threats regarding to data analytics? So we have some application types. When you use smartphone applications, usually the privacy risk could be an information theft or intrusion. So when you use e-commerce sites, so all of us are using probably, so it's involved with inference attacks or disclosure. When you use social media, the most important privacy risks are cyber stalking or ransomware. And also we are using banking, hospitals, insurance, government portals. These sort of systems has some privacy risks involved with disclosure or discrimination. So what we could do about privacy preserving the data publishing and analysis. I just want to take a closer look at the part of data publishing, which is data sharing, we could say, or the data release. So this is very important to emphasize importance of privacy. So this, when we use data publishing, it means that we are aiming to share data sets to the public users. So this data usually associated with some personal information. I just want to introduce Alice, Bob, and Kâtip. They are fictional characters. Usually we are using these person names in cryptographical states, cryptographical problems, with the problems related to privacy. So these are the persons, fictional characters. So what happens, you know, the privacy violation may occur in both stages. You know, when you get personal information from the person to original data set to creator, or from creator to the user by aggregating the information. So there are two main phases about data before data analysis: data collection and data publication. If creators are not trustworthy, so personal information will be disclosed directly in data collection stage. And even if the creator is trustworthy, still, and even if the creator applies some anonymization techniques for the personal information, still, you know, these personal information may be disclosed as the public. We could, you know, see both of them. So that's why privacy preserving methods become very, very important and urgent issue that needs to be addressed recently. So what we could do about the privacy model. So the privacy model needs some processes. The personal information before submitting to the untrusted creator, or before the, you know, the taking it to the user. So to preserve the privacy, you could put some private model in between of these two parts, in these two stages, between the, you know, the person to creator or creator to user. So these are very important. And the privacy model processes the personal information before submitting to the untrusted creator is important. And the other part is also, again, very, very important. So all data go through the privacy model should satisfy some requirements of the model. So now, actually, I just want to give some specific examples using COVID-19 data. All we know that we met the pandemic about 2 years ago, and these 2 years were very important for all of us, and it caused very rapid change in technology, especially in the industry and also in healthcare issues. So for this reason, I would like to give my examples about data privacy through this subject. So what happened? Countries, the many countries are now developing various strategies against the epidemic threat. The main ones are to increase social distance rule, hygiene rule, and also technology about mobile or web-based applications. So these are also studies on the course of the epidemic and human behavior by following social media flows, because we start to use social media much more before before every day we are using even me I wasn't using Facebook or Instagram or anything, but now I'm always checking what's going on. So it's so important. And many people, when they are when they were staying at home, especially in those days, they shared everything in social media, and they just wanted to buy, the many things from via websites, e-commerce sites. So the increasing amount of data with the rapid advancement of technology, especially in healthcare, gave us more accurate results and strong prediction models, especially in healthcare. So improved the clinical decision-making process and patient care. But we just have to thank to artificial intelligence and big data scientists. This was very important also thanks to deep learning. So using all these technologies, now we could easily, analyze the radiology images, which were very important in the, the diagnosis of COVID-19. So this is very important. But what happens? Actually, there are many tracking applications as well, and someone is watching you. Just be careful, just attention. That's very important. So the estimated data amount is actually expected to be in the range of yottabytes now. There are a lot of data everywhere coming. And this increased amount of data also poses big threat to control of privacy risk, because now we are having data from I'm talking about healthcare, but please, extend it to everywhere. It doesn't matter. Even you just think of very specific, sector, healthcare. You are having lots of, information from health sensors, medical imaging data, laboratory test data, laboratory test data from electronic or analog patient records, clinical and pharmaceutical invoices. When you stay in the hospital, they will give you some invoices. They all have personal information. That's why they pose a big threat to control of privacy risk. So another thing is the web-based or mobile applications. Okay, we are using these applications to reduce the spread and the economic damage of the epidemic by making use of COVID-19 data sets, but they use direct or indirect location information. We call them is absolute or relative location information, and also characteristic data defining people. These are the important things. So how can we manage privacy issues? There are regulations in Europe or in USA and in Turkey. GDPR and KVKK are the most important ones. HIPAA is related to the health sector in USA, and we have to obey these regulations, and also we need to use some privacy preserving technologies. So actually we were using the cryptographical methods such as K-anonymity, T-closeness. They were the most popular cryptographic privacy models. But now, with the increase of artificial intelligence and data mining usage, machine learning algorithms, so these methods are starting to fail. That's why we need to find new models for ensuring the privacy. So researchers actually were not concerned with the privacy issues a few years ago when we just first started in our PhD study of my student, when she studied that the subject at that time a few years ago. She is now just about to finish the work. When we started that one, there were very little, the papers, research papers about this. But the thing is that, the most popular, algorithms started to fail. Now, privacy concerns raised by the increasing prevalence of AI because AI itself, AI applications itself also are vulnerable to data theft, data manipulation, and model theft. So it compromises the privacy of the individuals represented in the data sets used. So this is also important. So what we can do, actually, now I just want to give you 3 examples of privacy enhancing technologies, but in our work, we are using differential privacy and federated learning, and we are focused on differential privacy. It's a strict mathematical definition of privacy, and the differential privacy model is a solid privacy model that provides a provable privacy guarantee for individuals. So it shares information about a data set publicly by defining the pattern of groups while keeping individual data in the data set. So it's achieved by using randomized mechanisms. So the image on the left shows a basic attacker model. Suppose a creator would like to preserve privacy for records in a data set D. You see there is a data set D here. So an attacker has all information about n-1 records in data set D, except the nth record. So these n-1 records can be defined as background information, and then someone could make a query on the data set D to get aggregate information, and also the attacker can easily identify the information of record N. But differential privacy aims to resist the attacks. So in this case, when the attacker makes the query upon both data sets, that attacker has a very high probability to get the same result. So the extent is insane, since the attacker cannot tell the difference between D and D prime data sets. So this is very important. That's why, compared to the previous privacy models, differential privacy can successfully resist background attack and provide a probable privacy guarantee. So another model is homomorphic encryption. So in this approach, it enables performing computation on encrypted data without decrypting it. So it provides secure aggregation by protecting gradient or model inversion or attacks on untrusted server, while differential privacy adds some randomness into data to prevent de-anonymization strategies from succeeding. Homomorphic encryption adds a security layer by providing some kind of machine learning algorithms to run on data without decrypting it. So the last one that I would like to mention about privacy enhancing technologies is the federated learning. Actually, it's a distributed machine learning strategy. Federated learning generates a global Okay. I think someone just put my voice. So, okay. Sorry about that. So the federated learning is a machine learning strategy. It's a distributed strategy, and it generates a global model by learning from multiple decentralized edge clients. So it actually lets us do machine learning while keeping data on device. So you don't give your data to somewhere else. It's not going through the cloud. You know, it's evaluated in your device as well. So in your mobile phone, for example. So that's why it's a very important model as well. So we did some work. Actually, our previous works, beginning works, it was about at the beginning of COVID-19 pandemic stage. These are, you know, the published ones. Now we are just preparing a thesis. My student just about to present her thesis now. We actually considered two critical application sites. One of them is healthcare. Okay, we use some COVID-19 data, and we tried to use differential privacy, how it affects the model. We tried to use it, and using efficient net and CME network now. Now we are also using CME network. And now we focused on another important critical application area, which is the biometric identification, person identification, or you know, the recognition systems. So we also use signature recognition problems. The thing is, the more privacy means less accuracy. The important thing is, research subject is that how we could, you know, get secure, private, and also accurate models. This is very important. This is not an easy thing, because when you increase the privacy, you have to sacrifice the accuracy. That's why this is a very open research work, I just want to say. Actually, I like these things. Albert Einstein says that, you know, at the heart of the challenge lie opportunities. So I'm just saying that, you know, we are now looking at the tip of the iceberg. We don't know what you know, the exactly what awaits us underneath. But the thing is, whatever it's underneath, so it will shape our future work of data scientists, artificial intelligence scientists. It will shape the future of it. So again, I just want to say that at the heart of the challenge, like many opportunities for researchers. So thank you very much.
Sayın Profesör Doktor Tülay Yıldırım'a teşekkür ederiz. We would like to thank Professor Dr. Tülay Yıldırım. Şimdi de davetli konuşmacımız Sheffield Üniversitesi'nden Sayın Doktor Franco Bartnalı, Exploring Lifelock Archives, A Case for Data Scientist başlıklı konuşmalarını yapmak üzere arz ederim. Now, I would like to invite our invited speaker, Dr. Franco Bartnalı from the University of Sheffield, to give his speech titled Exploring Lifelock Archives, A Case for Data Scientists.
Thank you very much. Can you all hear me?
Yes, please.
Okay, perfect. Well, thank you very much, first of all, for inviting me, and thank you all for coming to listen to my talk. So my name is Franco Bartnalı, and I'm going to talk about exploring Lifelock archives, which I want to show you is really a case for data scientists. Let me first start by introducing myself properly. So I'm right now working at the University of Sheffield at the Information School as a senior lecturer in data science. in Sheffield, I'm also the head of the Information Retrieval Research Group. We work on many topics related to information access, which includes information retrieval, but also recommender systems, also looking at algorithmic bias and similar topics. So my main research interests are, in fact, on information access, which includes recommender systems and information retrieval systems, multimedia analysis, and self-tracking. So what I'm going to talk about in this talk. So I want to promote further research on the data analysis of Lifelock archive. What I mean by Lifelock archive, I'm going to show you in a minute. Before I start, I of course want to emphasize that I'm really speaking today on behalf of my collaborators who contributed significantly to this work here. So that is first of all, Carol Gerwin, who is the main lead on this project, is from Dublin City University. Then my colleague Hideo Joho from the University of Scuba. Then Daktian Dang Yun, Li-Ting Zhou, Rami Albatal, and Graham Healy, coming from different institutions as well, who all have been contributing to this work as well. Okay, so let me first say, say that an observation that probably all have made, that nowadays we all generate massive amounts of personal data. Yeah? So if you think about all the tools that you're using every day, you might use, well, you might be tracked somewhere. Yeah, so basically it's a lot of data that is created either by ourselves or about ourselves. And one potential outcome of this creation of data is life logging. So life logging means that we as individuals, we log our life experience into a digital self. Yeah? So which means that we create a lot of personal data. And if you would aggregate that, you could learn a lot about us as individuals. So because this is now technically possible, and in fact it's happening, we need to understand how to support search and retrieval of this data. Yeah? So how we can get access to this data. Let me just give you a few examples. So can I get a quick show of hands? So who of you has heard of quantified self? Could you write in the chat window if you have heard of it, or you have not heard of it? Please write yes or no. Okay, yes, no, I have not. No. Okay, so it's quite a few people who have not heard of the term itself, but I'm pretty sure you are familiar with the concept. So you see here on the picture, this lady is wearing a Fitbit. Yeah, so it's or she's wearing a wearable device that you can use to track your steps or your sleep patterns. Then maybe let me ask you differently. So who of you is familiar with such devices? Again, can you please write yes or no? Okay, so they're becoming quite popular these days. And so there's a movement that has formed over the years of people or enthusiasts who like to rely on these devices to learn more about themselves. And this movement is now referred to as quantified self. And so it means basically you gain some self-knowledge through numbers. Yes, you learn more about your sleep patterns by looking at how many hours you sleep, what is your REM phase every night. You learn more about your physical activities by maybe you're familiar with Strava, where you can track your running patterns, how long you run, or your heart rate is going up or down. Yeah, so there's a lot of data, personal data that can be recorded using these devices. Okay, so these devices are one thing, but of course, if you think about your smartphone as a mobile sensor platform, which actually it really is, this device also records a lot of data about yourself. Yeah, so think about all the different apps that you're using on it. So if you're using it to for navigating, for example, right? Let's say you use Google Maps, you're creating a record, personal record of where you are going. Or if you're using it for checking up on news, again, there's a personal record created about yourself. Yeah, so you see these smartphones, in fact, they can be seen as an entry device or as an enter device that we use to create a lot of personal data about ourselves. Here's another example that most of you probably are not familiar with, however, which is a product that might become more visible in the next few years. I mean, it has been around for quite a while now, but hasn't quite completely caught up yet, although technology is improving. So what you see here on this picture, this is called, this particular device is called a narrative clip. What it really is, like this category of devices called Lifelock camera. So what this camera does, again, you wear it just here on your jacket or your shirt, and what it does, it automatically takes pictures. It takes pictures every few seconds, which means that you can create a very personal visual record of your day's activities. And these are becoming very cheap now. So this narrative clip here, for example, is the device that you see here. When it came out, it cost only $150. And it has an SD card in there or a memory in there that you can store it stores the pictures that it's automatically taken you. In the evening, you just copy them to your computer and then you can use it again for the next day. Okay, so again, to repeat what I said earlier. So imagine now we create all this different data using different devices, using mobile phone, using cameras even. And now if you think about the technology that you have available nowadays, so if you think about deep learning techniques, really digging into the data, there's some big data analytics approaches. This can really help us to create what you might call a digital self, yeah? So get a digital representation of your interests, of your behavior, of your activities. Yeah, and the challenge that we are looking here now is like, how can we create such a digital life log of life experience without manual input? Because as you can imagine, if you constantly create this data, it's getting so much data that you cannot expect people to manually do it. It has to be done automatically. And already, in fact, it's already created automatically. It's just not aggregated or analyzed properly in the way we envision it could be. So it could entail activities, experiences, interactions, emotions. So a lot of data. And the challenge now is, okay, how can we make it useful? Why do we want to do this? Why would we be interested in actually analyze this data? Well, there are many different reasons, and here these are a few points that have been pointed out by Selen Whittaker. You have the information, the details about their publication where they talk about this on the bottom of this page here. So basically, oops, sorry, just have to move away the chat window here. Out of the way. Okay, so it might be that you want to just use it for retrieval purposes. Yeah, so you want maybe find an item in your digital self, so or validated memory. Let's say you want to relive the moment where you went on holiday before your last holiday before the pandemic kicked in. Yeah, maybe you want to find pictures of this, or it could be for reflection purposes. Yeah, in particular, if you think about the quantified self data that I mentioned earlier, you might be interested in reflecting a little bit of, am I physically active enough? Should I do more? How about, do I sleep enough? And so on, yeah? It might be that for reminiscence, so you might be interested, for example, to find and share items. Let's say you want to share pictures of your last holiday with whoever you have met there, with whoever you went on holidays. It might be used for to remind you. So let's say, for example, you have an upcoming event and you need to have, you have a few things that you talked about before that you have to sort first. If you have this in yourself, in your record, then there might be a task for recommender system to recommend you or to remind you that this is still a task that you have to do. It might be for representation. So you might have, if you think a bit further going into the AI domain, you might have digital agents that act on your behalf. That could even be during life, or it could even be after life. Yeah? So that would still be, you would have a digital representation about yourself after you died. And finally, it could be for protection purposes. So it could be for protection of yourself and bystanders by having a look at the data. Okay, so now think about all these different activities or different motivations that are out there. There's clearly a motivation to develop what you call a collaborative benchmarking activity. Yeah? And as I will show you later, collaborative benchmarking activities are actually core to advances in the field, because if you're not able to compare your algorithms, your methods to other algorithms that have been using similar data, the same data set, or using the same conditions, then it's very difficult to say really if what you have developed here is representing the current state of the art from a technical perspective, or if it doesn't. Yeah, so that's why it's very important to actually have these collaborative benchmarking activities. And that's why we have organized a campaign to advance data analytics research from Lifelock archive. Yeah, so we wanted to provide data and a framework to guarantee that we can actually study all these things, or they can address all these reasons for Lifelock analytics that I showed you on this slide here. Okay, so this was the motivation of the work that I'm talking about to you. What I'm going to talk about next is I'm going to give you a brief overview of collaborative benchmarking and of this particular activity that we have been doing. Then I'm going to introduce you to the data sets. Then we're going to look at the different tasks that we introduced, and then have a brief conclusion and trying to motivate you to have a closer look at this data set as well. Okay, so let me start with this motivational slide here, why we need test collections. This one here is a quote from a research report from Kâtip Jones and Keith van Rijsbergen that they published in 1975. So they are, if you're not familiar with these names, they are leading researchers in the field of information retrieval. And they have in fact pointed out very early that there's a need for these joint test collections. So they say in this quote here, let me just read it out. At present, too many projects are working with different collections. This leads to unnecessary data preparation effort by each project. It also accounts for much of the project disconnection that exists. This makes it difficult to correlate the results obtained by different projects. Yeah, so back then, 1974 and the years before, basically what's happened was that if anyone who wanted to do research on information retrieval, yeah, so search engine optimization, they had to create their own data set, and then they had to identify, okay, these might be suitable metrics that I want to use to see how good my system is working. And this work here, this paper here, in fact, has led to the development of test collections, not only in the field of information retrieval, but it went on, of course, in other fields as well, machine learning, multimedia analysis. Yeah, so wherever you are using test collections nowadays, this is basically where the idea came from. But it's not enough to just have these test collections. We need to also have talk about the right conditions and metrics that you want to use. And here is where NTCIR comes into play. Again, can I ask you, please, if have any one of you heard of NTCIR? Can you please type in the chat window again, yes or no? Okay, yeah, I'm not too surprised, to be honest, that you didn't come across it before. So NTCIR is a research workshop that is happening in Japan every 18 months. It's called, and NTCIR stands for NII Testbeds and Community for Information Access Research. Basically what it is, it's a series of evaluation workshops which is aimed to promote research in information access technologies. And they do this by providing an infrastructure as well as data sets, evaluation methodologies, and provide a forum to work on specific topics. So it has been running since 1997. Again, it's based in Japan. So it's mainly focusing on the Asian market. Now, there are, of course, other campaigns like this. There's international ones. There's one in Europe, American-focused one. You have it at major conferences nowadays that you have a challenge where they provide a data set and you have to complete tasks. Yeah, so it's a very common one. So this one here, NTCIR, is just one out of many where you can get access to data sets, and we can get access to evaluation methodologies and then present your work. So I'm introducing this one to you because we actually submitted a proposal to host an activity on live logging to this workshop series here. So they do many different things. They focus on they have many different data sets that they have released over the years. So on focusing on scientific data, news, patents, web data, question answering, Wikipedia data, exams, microblogs, and now also live logs. You see, it's a lot of different data sets that they've released over the years. So we have first introduced, so again, this is happening every 18 months. The latest one is NTCIR 16, which is happening in this month and in June 2022. And we have been introducing live logging a couple of years ago at NTCIR 12, where we introduced over the years then different subtasks. We focused on live log semantic access. We focused on providing insights into live logs. We had something about event segmentation, an annotation task, and a live log activity detection task, which I'm going to talk about in detail later in this presentation. So again, this has been running for quite a few years now, and we were quite pleased to see that we had then teams from, well, many different countries expressing interest and in participating in these activities. So basically what happened was then that each year they downloaded the data set, they completed, they provided, they tried out different algorithms on these data sets, they sent us their results, we evaluated the results and compared them to the other participants. And then there was a workshop in Tokyo happening where people could present their findings. All right, but let's have a look at the data to see what this actually looks like. So we provided a multitude of different types of data. So we had variable multimedia data, which were basically created using the live logging camera I showed you earlier, so the narrative variable camera. Roughly 1,500 images per day we created, and we included also concept annotations that we created automatically, sometimes audio recordings, also people, like our live loggers who contributed the data, took pictures manually, and we also recorded their music listening behavior. We also recorded human biometrics, which includes heart rate, galvanic skin response, again, all using a sensor, calorie burns, steps, step counters, skin temperature. This was all recorded automatically, but then also some manual activities like daily blood glucose level and the blood pressure. We also looked at weekly cholesterol and uric acid measurements. Again, of course, this was done manually. We recorded data for information access, so basically recording what people were reading on their screen, like what keys they were typing in, mouse movements they made, other computer activities, and web pages they visited. And finally, we recorded some human activities, like physical activities, like walking, running, use of transport, and so on, locations they visited, food they ate, and their mood. Of course, now you see some of these were recorded manually, some of these were recorded automatically. So let's have a look at these a bit closer. So let's look at the biometric data. So we looked at blood pressure, again, recorded manually, glucose level, heart rate, galvanic skin response, calorie burns, and steps. So you see that we use specific apps for these to record these, and this was the visualization that we got from these apps as well. And we could extract this raw data then. This is just the overview of the computer activity or the information access activity. You could see like the web pages people were browsing, how they moved their mouses, their mice, the words written and that they were writing. We grouped it into minute-long documents with term frequency, which allowed us, for example, to create a tech cloud like you see here to look at what people were interested in. Then for the physical activities, we asked the Lifelockers to take pictures of the food they were eating. We asked them to manually annotate using an app to let us know what their current mood is. So this was an app that was constantly reminding them throughout the day, please let us know what is your mood right now. We were tracking the locations using an app on the phone that was keeping track exactly where they are, so it's constantly running in the background. And also physical activities, which was also done by the app itself. It was knowing, for example, okay, this person now seems to be taking a car or bus. This person is now walking. Now it's on a bike and so on. Yeah, so it's a lot of pre-processing done, data analyzed already by the apps themselves. But we were just recording, downloading the data, the analysis that was the output of these data sets. Of these apps. Then here's a few examples of these pictures that were taken by the wearable camera. You see them. That of course, if you have the camera here in front of your chest, then that's the perspective that you get on the picture. So some pictures, they are very blurry. Some pictures, they are quite focused on what the person actually see, but of course, you have slightly different perspective because the camera is a bit lower. We also asked them to create manual photos. We had some periodic audio we were recording. And as I said earlier as well, we were recording their music listening. Yeah? So if they're walking somewhere, had headphones in their plugged in the phone and were listening to a music app, we were recording what they were listening to. So here's an overview of the data set that we created. You see here, we started with 3 Lifelockers. We were recording the data, or providing us the data for over 90 days. Now over the years, the number of Lifelockers went down a little bit. Unfortunately, at the end, we had 1 Lifelogger who was providing data for over 120 days. But you see that the data set actually was increasing over time. So for example, in 2016, we had over 180,000 images provided by the Lifelogger. We were using things like Last.fm to record the music listening activities. We're using an app called Moves to record physical activities, and ask them to manually record the diet and manually take conventional photos. All right, so that's what the data set looks like. And now let's have a look at the tasks that we did. So we focused mainly on 4 tasks that I mentioned earlier already. The first one was called LAT task, which stands for Lifelock annotation. So the idea was we want to test multimedia data analytics tasks. Yeah, so people or the researchers were asked to automatically annotate the visual Lifelock data. Yeah, so basically images that were recorded automatically. In the LSAT task, which is a known item search task, here the idea was to advance research on on Lifelock retrieval. Yeah, so search engines on this Lifelock data. Then we had our LIT task, which is an insight task. Here we wanted to focus on the data visualization. So can you create some nice visualizations of the data? And finally, we have the LEST task, which is an event segmentation task, where we were asking participants to, okay, here's my stream of data. Can you segment it into different activities that I have done throughout the day? again, let me give you a few more details on this. So the Lifelock annotation task basically was all about identifying specific activities that people were doing throughout the day, like looking at the data. Is this person right now socializing? Are they watching TV? Are they exercising? Are they shopping? Or what are they doing? Yeah? So these were activities that we asked them to do, to identify. The known item search task here is an example. So here they would have to, we asked them to retrieve a number of specific moments in a Lifelocker's life. So it could be, for example, moments where we asked them, well, find all the moments where I was boarding an airplane, or where I am in the kitchen, where I'm preparing my dinner, where I'm playing with my phone. Yeah, so they would get a description like this, would give them a title, the description, and then a little narrative to help them to put this question in perspective. Yeah, so this is a very common task in information retrieval research. This event segmentation task was, again, here's my stream of activities. Now, can you identify specific events? Events throughout the day could be waking up, preparing breakfast in the morning, waiting at the bus stop, or commuting to work. Yeah, so you can have events like in different granularity. It could be being at work, or it could be even more fine-grained. It could be checking your emails, responding to emails, well, attending a meeting, giving a presentation, and so on. Yeah? So again, this could be different activities, different events that you have. And the task was, can you identify different events that we have in our data? And finally, the fourth one, which was the Lifelock Insights task. Here we were just asking them, okay, this is the data. Now create some nice visualizations of this data. So it's almost like creating themed diaries. Okay, so again, this was just to give you an overview of the activity. Now let me come to my conclusion. Basically, my conclusions are a call to action for yourself. So what I've shown you here is a very rich and multifaceted data set. And also it contains very clear evaluation protocols. Therefore, the different activities that I've shown you there, we have not only provided a data set, we have also defined how you would have to run your experiments, which is very common in these evaluation campaigns. And also said, okay, these are the metrics that you have to use. Because we already have participants using these data sets and participated in these, we already have established a baseline. So baselines mean basically, baselines represent the current state of the art in, well, let's say, for example, event segmentation for Lifelock data. And these were developed by renowned research teams that you saw the map of the globe I showed you earlier of the teams coming from different places. Yeah, we have from many different really experienced research groups who participated in this activity. So hopefully that motivates you as well as researchers or emerging researchers to take a look at this data and say, well, maybe you want to try out some algorithms as well to work on this data set, because again, this kind of creation of personal data is a very trendy topic and is going to be increasing in the next few years because we're going to create much more and more data. And this data set gives you actually an opportunity to, well, to dig into it, to try out your algorithms, to try out different methods, to see how you can, if you can provide some insights on such data. If you want to learn more about this, I would like to recommend this book chapter that we have published last year. It's an open access book chapter, so you can download it for free, where we basically summarize the experiments in Lifelock organization and retrieval at NTCIR. It doesn't include the last year, so this year's Lifelock campaign that we have, but the 3 ones before that we have all covered in there. And finally, my last slide, if you want to have a look, please come and have a look at this website here to learn more about the activity and how you can get access to the data. And that's me done. Thank you very much for listening. And if you have any questions, please let me know.
We would like to thank Dr. Frank Hofgartner. Sayın Dr. Frank Hofgartner'a teşekkür ederiz. Şimdi de davetli konuşmacımız, adres gezgini, kurucu ortağı Sayın Dr. Şükrü Ozan'ın The Importance of Deep Learning and Machine Learning in Call Center Operations başlıklı konuşma videosunu arz ediyorum.
Hello, and welcome to my presentation titled The Importance of Deep Learning and Machine Learning in Call Center Operations. I am Şükrü Ozan. I am Research and Development Center Manager of Adres Gezgin Company. Today I will mainly talk about the data projects we have been managing in our company. They were mainly concentrated in call center operations and solving problems corresponding with call center operations. Adres Gezgin Company is mainly a digital marketing software development company. But in our Research and Development Center, we are also performing machine learning and deep learning projects. We have already finished a couple of projects successfully. So since 2017, in our Research and Development Center, we already finished 4 data projects. And now currently we are managing 3 consecutive data projects. First of all, I want to talk about Call-Tech Data project. So Call-Tech project mainly concentrates on finding and analyzing call center calls. We needed this software because in 2014 we came up with a collective fraudulent behavior of call center agents. They were making fake calls. So it was not easy to detect an anomaly in any call performed on our call center, because in each day in our call center people are performing hundreds of calls, and it's not easy to listen to them one by one. This system simply analyzes call center calls by using a convolutional neural network and segments the call recordings into four different segments like speech, silence, music, and noise. Analyzing percentages of these segments by using conventional machine learning methods is very successful in finding anomalies in the calls. And within these anomalies, after detecting these anomalies, it's easier for a manager to listen to selected anomalies and decide whether this is a real fragile behavior. This was the first phase of our Call-Tech project. I will talk about the second phase in the later slides. In this study, as I have already said, we analyzed each call center recording by using a convolutional neural network and simply find segments, and we also created our own features by using the statistics of these statistical distributions of these segments, and we generated features like percentage of silence, non-silence ratio, position of long silence, and features like that. So by using these simple features, it's easy to use them in a conventional machine learning methods, and it's really very successful in finding anomalies. Secondly, I want to talk about our botchat.app project. So botchat is actually a chatbot, and it's specifically trained with our data by using NLP methods. So eventually we used a transformer model called BERT, and the aim of this project is to answer site visitors' questions if there's not an available customer representative online. So I want to show you, maybe I can show you a real-time demo. So this is our website, original website of botchat.app. So we already implemented our chatbot here in this website. So there isn't any online customer representative now. So it asks for my name, my email, and my phone number. So we can start chatting with the chatbot. So I first greet the bot. So it asks for, how can I help you? And I just want to ask some simple consecutive questions, were basic questions like, it understands the question and request of the visitor, and it just prints the most convenient answer selected from our database of answers. So it's using BERT to semantically understand what the site visitor is trying to ask and finds the most convenient answer. And it's most of the time is the most convenient answer. So I'm now asking you another question, like, and it's now giving another appropriate answer, and again asks for anything if you want anything else. So I just want to ask how we can reach the company, and it gives the most convenient answer again. So at this point, its site visitor may just want to quit chatting and can rate the chat conversation, and that's it. So we already finalized this project, and as I said, for this project, we eventually used transformer method called BERT, but previously we tried more conventional methods to that time, like fast text, word flag, and dot flag, and fast sentence, things like fast sentence embeddings. And we also wrote conference papers and some journal papers during this project. So this is the second part of the COLTEC project we previously talked about. In the second phase, our main aim is to provide automatic detection of emotional changes, which constitute a great problem for customer satisfaction. Mainly what we want to find argumentative conversations occurring between a customer representative and a customer. So it can be both sides. It may come from customer, it may come from customer representative, but either way, if there is a problem, it's always convenient to figure it out as soon as possible and generate an alarm for the managers. We implemented the main idea of this project by using audio recordings, which were manually labeled, and by using MFCC features and convolutional neural networks, we achieved 85% of accuracy in finding negative emotions in audio recordings. But and we are very close to implement this idea in our COLTEC.app project. And in this project, we also compared the results with the Gaussian mixture model, which was trained with conventional features, and we also compared it with the results of CNN architecture, which was trained with MFCC features, and we achieved a better result with convolutional neural network. We also extended this idea to our current project, the ongoing project, which I will talk about right now. And this is our speech-to-text project called Lingo.app. Lingo.app was actually my ultimate goal in analyzing call center calls. Our main goal was to convert each possible recording, each possible audio call to a conversational Turkish text, which can lead us to solve any problem by using NLP tools. It also includes the second phase of CallTech project, which is finding negative emotions in conversations. It is theoretically possible to find negative emotions by analyzing conversation text by using natural language processing methods. So in this project, we trained a speech-to-text model, a very state-of-the-art speech-to-text model called Lifelock, and there are nearly 100,000 of training data. And now to some extent, we successfully trained a speech-to-text Turkish speech-to-text model, which can robustly convert call center calls into a conversational text. We use the speech-to-text model, state-of-the-art model, which is based on transformers called Lifelock by Meta, a Facebook company. And this is the original web page of lingo.app project. We also designed this project as an API, which other companies can subscribe and use it by buying some credits. And we are very close to publish the first version of this API. And moreover, we also embedded lingo.app into CallTech project. So I can show you the main screen of the latest CallTech.app project. So this is the main screen of CallTech.app. In this screen, we can see basic statistics of the current day. So this is the main screen of CallTech.app project. What I want to show you is to show the lingo.app in action. So this is a conversation between our customer representative and a customer. So we can listen.
İyi günler, Burkan'ın nasılsınız? Teşekkürler, iyi. Aranızda sabah. Evet, evet.
Biz geçen günkü görüşmenin üzerine düzenlemeyi sağladık hani tek kampanyada.
So I just wanted to show a little bit of the performance of our speech-to-text model. Call center recordings are very challenging because they are recorded, especially in our call center. Our calls are recorded as mono-channel audio files, and they are compressed too much. So as you can hear, the quality of the recordings are so bad. But since we already trained our model with thousands of these call center recording samples, it can robustly convert speech to Turkish text with a very high accuracy. So now we are able to convert any conversation performed in our call center and store it as an individual text file. And later on, any NLP task can be implemented by using these text results. Thank you very much for your participation. If you have any further questions, please feel free to reach me out. And thank you for your participation and for your patience in listening to my presentation.
Sayın Doktor Şükrü Ozan'a teşekkür ederiz. We would like to thank Dr. Şükrü Ozan. Saygıdeğer konuklar, kongre programımız saat 14'te başlayacak olan akademik bildiri sunumları ile devam edecektir. Katılımlarınız için şükranlarımızı sunarız. Dear guests, our Congress program will continue with the academic paper presentations that will start at 2 p.m. We thank you for your